Okay. Can anyone tell me now what is the given data? Just read out the problem. First number and answer. Read the problem. The refrigerating machine takes 1.25 kilowatts. So that means the energy consumed by the machine to do some work. So that is called as input or W. So kindly pay attention. So the problem it is not so much simple as when we have in the previous class, that is IC units. Okay. So the total work input, that means the amount of work required to do the refrigerating effect is how much? 1.25 kilowatt. Correct, sir? So next one. See, it is going to produce. So this is a work input, right? So input. Okay. So how much amount of ice it is producing? It is producing M is equal to 25 kg per hour. So it is going to produce a mass, 25 kg of ice per hour. So next one. From water, okay, initial temperature of the water is from 30 degrees Celsius to 0 degrees Celsius. So initial temperature of the water is 30 degrees Celsius, and this water is being converted to ice at 0 degree Celsius. Okay. Next, what else are given? First. So what we have to find out? So we have to find out refrigerating effect. That is Q. We have to find out. Next, tonnage. So whatever the refrigerating effect, so that will be in terms of kilowatts or kilojoule per second or kilojoule per hour. So this has to be expressed in terms of what? Tonnage. So that is, we have to express this in terms of tonnage. So what is 1 ton is equal to how much? 210 kilojoule per minute or 3.5 kilowatt or kilojoule per second. Okay. So to convert this refrigerating effect to tonnage, so we know that 1 ton is equal to so much. Okay. So next, what else we have to find out? We need to find out COP, coefficient of performance. Right. So these are the main 3 items that we have to find out. Okay. So they are given the specific heat of water is how much? 4.18 kilojoule per kg Kelvin. Next, latent heat of solidification. So latent heat of solidification is how much? 335 kilojoule per kg. So these are the data available. Okay. So in the previous problem also we have solved similar type of problem. So where we found out the refrigerating effect. Okay. So what is the refrigerating effect? RE, that is equal to Q is equal to M specific heat of water into delta T. Right? So we have used this formula in the previous problem to find out the refrigerating effect. Here one term extra is been given, that is latent heat of solidification. What is the meaning of latent? Specific heat of water, and what is latent heat of solidification? That is very important. What is the meaning of specific heat of water? Means if I need to reduce the temperature of the water by 1 degree, or if I need to raise the temperature of water by 1, not degree, it is 1 Kelvin. Okay, so the amount of heat required or amount of heat has to be extracted. So that we are going to call as what? Specific heat of water. Have you understood? To change the temperature of water by 1 Kelvin. 1 Kelvin. So that is the amount of heat required or to be removed to change the water, to change the temperature of the water. So that is what the specific heat of water. Next, what the meaning of latent heat of solidification? So that means we are changing the phase of the water. So liquid state to solidification, right? So liquid state to solid. So we are converting the water from liquid state to solid state. So for that, how much extra amount of heat is need to be extracted? Is it clear? So this is per degree change. This is for the conversion of phase from liquid to solid. So therefore, in this problem, so refrigerating effect, that is Q, is given by mCpW delta T. So that is from 30 degree to 0 degree Celsius. Okay, plus M into LS. So this is for the phase change. This is for the phase change. Are you able to understand? So this is the amount of heat need to be extracted so that I can convert the water from 30 degrees Celsius to 0 degrees Celsius. Okay. So now what is the mass? 25. What is CPW? So I am going to take the mass as common because both the case M is same, 25. So what is CPW? 4.18 into delta T means what? Difference in temperature. Difference in temperature. So there you are not going to get any negative and all. Only it is going to tell you the difference. What is the difference? 30 degree plus what is LS? 335. So therefore, what is the value of T? That is the refrigerating effect.
11,510.
What's that?
11,000.
11,510 kilojoule per
kg per hour.
per hour. Right? So here we are going to get in terms of kilojoule per hour. Any doubts here? I thought you were going to ask me a doubt. Sir, here there is a CPW, that is kg Kelvin is there. So, but we are telling that is 30 degree to 0 degree. It is in Celsius. Okay. See, here we are taking the difference. Even if I convert the temperature from degree Celsius to Kelvin, how to convert? I am going to add 273. Okay. So then the difference will be same. So that's why we are not converting degree Celsius to Kelvin. Is it clear? So now we got the refrigerating effect is equal to 11510 kilojoule per hour. So first point is over. Now we need to determine the tonnage. Okay. So in terms of ton. So what is the ton? Refrigerating effect 11510 divided by. So 3.5 kilojoule per second. So how much are we going to add? So 3600 into 3.5. Is it right? No. See here, this is in terms of kg per hour. So I need to substitute this tonnage in terms of kg per hour. So to convert joule per second to kilojoule per hour, I am going to multiply 60 into 60. So then it will be 3600. Okay, how many terms? How much terms? 0.913. 91. So this is the tonnage capacity of the refrigeration system. 0.913. Next, what else we have to find out? Specific. What is it? COP means what? Coefficient of performance. Okay, COP means coefficient of performance. What is COP? COP is equal to Q by W. See, what is the unit of Q here? Kilojoule per hour. Okay. So what is the unit of W here? 1.25. So that means it is kilojoule per second. Either you have to convert this to kilojoule per hour, or you have to convert this to kilojoule per second. So which one you are going to do? So I am going to substitute this 11510. So to convert this kilojoule per second to kilojoule per hour, what I should do? 3600 into how much? 1.25. I am trying to convert from kilojoule per second to kilojoule per hour. Okay. So what is the value of COP here? 2.5. Is it clear? So this is how you are going to solve the problem. I hope you understood the problem.